So I think we're gonna start off by just getting engaged in the room, going around, just everyone introducing themselves and just saying a little bit about their background. I'm ready to go, so.
Sure. So my name is Andre Antunovic. I'm a fourth-year computer science student. I'm also doing an electrical engineering minor. I'm an international student from Veale, North Macedonia, and my interests are computers, languages, music, and sustainability. And I want to somehow combine at least 2 out of 3 of those to make the fourth one happen.
Hi everyone, my name is Keaton. I'm from California. I'm third year undergrad. I'm studying mechanical engineering, material science. And yeah.
My name is Oğuz. I'm a third year chemical engineering student. I'm also an international student from Istanbul, Turkey. And my research revolves around CO2 reduction, electrochemical utilization of CO2.
Hi everyone, my name is Marina. I'm an international student from Greece. I'm a undergrad third year in chemical engineering, minor in business management, and I'm part of Think Energy.
Hi, I'm Abby. I'm a fourth year biomedical engineering student on the biomaterials track, and I'm studying for I'm also a Think Energy fellow.
Hi, my name is Avinash. I'm from New York and I'm a mechanical and aerospace major. I'm a second year and I'm also a mechanical.
Hello everyone, my name is Xiao Tong. I'm a fifth year PhD student in physics. My research area is semiconductor transistors, and my energy interest is thermoelectricity or AI sponsored electrical platform. And I'm also a Think Energy major.
I'm Grace. I'm a third year electrical and controls engineering major. I'm from the suburbs of Chicago. And yeah, I'm also in Think Energy as well.
Hi, my name is Kayla. I'm a fourth year chemistry student, undergraduate. I'm from the Cleveland area, and I'm also a Think Energy fellow.
Hi, my name is Ben. I'm a third year mechanical and aerospace student. My bad. But I'm also a Think Energy fellow.
Cool. Hi, I'm Caleb. I'm a second year CS student who likes technology and sustainability. Also Think Energy fellow.
Hi everyone, my name is Adriana. I'm from Peru. I'm studying civil engineering, environmental track, and I'm also a Think Energy fellow.
I'm Bob Chownell, faculty member in the Department of Chemical Engineering.
I'm Darren. I'm a master's in entrepreneurial biotechnology student. My interests are in bioenergy. I'm a former distinguished Think Energy fellow.
Hi, Joe Jankowski. I am a senior advisor for innovation and economic development at CASE. And many years ago, my PhD was in environmental chemistry. So I love the topic.
Hi everyone, I'm Zay. I'm a fourth year medical student going to medicine in a few months. I am not a Think Energy fellow, but I'm one of the alumni venture fund fellows, and originally from Cleveland, Ohio.
And I'm Becca. I'm a past Think Energy fellow a couple years ago, so it's awesome to be with you all today. I'm a fifth year PhD student at the University of Pittsburgh and CEO of Flow Solutions.
I guess I can go, but I'm Brock. I'm a third year mechanical engineering major, and I'm leading the session today. So I just want to start off saying thank you, Becca, for joining us. And I was wondering if you could give us a little bit more insight into your specific career path, from undergrad to where you are now.
Sure. So I started at INS as an undergraduate chemical engineering student in 2016 here at CASE. And in my first year, I joined Bob's lab working with the flow battery project. And that pretty much sparked my interest in working with grid scale batteries. And so I took all the chemical engineering classes and focused a lot of my work on energy industry and market needs for batteries. And so through this process, I became a Think Energy fellow and worked at the Great Lakes Energy Institute one semester working on a white paper for energy storage. And so I think all of these things really catalyzed into what do I want to do next? How can I make an impact on the energy ecosystem in the best way? And so I decided, well, I want to start a company. So how do I do that? Well, there's a couple of different paths. I could just start a company out of undergrad, which a lot of people like do very successfully. It's hard. And I didn't think that was the right path. And so then I talked with a lot of my mentors here in chemical engineering. Dr. Veale is one of my favorite mentors here, also at Case. And I decided to do my PhD in chemical engineering and figure out how I could contribute technically to this field of energy storage and then spin a company out of that. And so then through my PhD at Pitt, I met my awesome advisors, Dr. James McCone and Dr. Chris Wilmer. And so we came up with the technology for battery diagnostics, and we're starting a company out of that right now. And so it's definitely been an interesting journey, and academia has helped a lot with it.
Makes sense. So a lot of people that will like talk to us each week, they kind of tell us about like where they are now, and they head on that they never would have expected that they ended up where they were. So I just wondering, would you say that this is where you like always saw the path your career is taking, or did it kind of like take turns?
I think this is like, I don't want to be annoying about it, but I feel like this is where I wanted to be. You know, like I feel like I'm the type of person who like needs to know what's coming next, and I'll plan for it like sometimes to a fault years in advance to kind of make it happen. And so I wanted to be like graduating my PhD now, starting my fundraising, hopefully fundraising our first rounds at this point, and then graduating later this year.
Yeah, makes sense. So can you tell us a little bit more about like your research specifically, like what you're researching and maybe how it actually developed into flow solutions?
Yeah, definitely. So my research project at Pitt, it's changed a little bit over the years, but what we work on are electroanalytical tools for flow batteries. And so we put together small flow battery cells in the lab, and then we cycle them. And what I worked on previously was this device where we could use an additional half cell. So you have 3 electrodes in a small cell, and you perform cyclic voltammetry, which is a type of electrochemical measurement on the electrolyte, basically your blood that's flowing through your battery. And so if you have this small measurement tool in your battery, you can detect important metrics like the kinetics of your reaction that's happening in your battery and state of charge. And so the technology here developed into, well, how can we best use it to service the industry of batteries? And so our initial idea was that we could have small testing batteries to test out different electrolytes and electrodes and membranes, all the different components that you need inside of your battery. And we can test that cheaper and faster than how it's done today. And that would help the industry grow, because the ones who are making batteries could then come up with their best secret sauce faster. And so we started down that trend, but it quickly switched into a larger market because we wanted to make a bigger impact onto batteries that are already getting onto the grid today. And so we, to answer your question, we had a bit of a pivot where we were looking at a different market and then switched over to grid scale batteries on that are in the field today. And we're using similar tools and detecting similar metrics, but on a larger scale.
So where are like the flow batteries that flow solutions kind of focused on? Like where would you most commonly find customers?
Yeah, so you can find flow batteries next to large fields of solar panels. A lot of these are used next to big generate power consumers like manufacturing plants, hospitals, anywhere that needs reliable backup power is where you will want to find a flow battery or other types of large batteries for long duration energy storage. So a lot of these systems are popping up on microgrids and on military facilities now where you need energy security as well. But in the future, there's the question of, well, you need reliable power for data centers. And where are you going to get that from? And so that's another good scenario for the future.
So a big part of Flow Solutions is providing deep insights into side reactions in the batteries, and then also predictive maintenance schedules. So, which obviously are helpful for the batteries, but like, do you have more like a quantitative, like how much it helps with this feedback helps with like the performance and longevity of these batteries?
Yeah, so I can kind of go into our thought process there without using any like particular, metrics that I can't share. But the thought is that from our customer discovery, which we've done over 150 customer discovery interviews, that's like definitely something that I've learned like that it exists in the Think Energy program. So like happy to chat more about that later. But the thinking from talking to customers is that some of the biggest failure mechanisms for flow batteries are side reactions where you're taking in power and you're not charging and discharging your battery with it. It's just getting lost. And so you are making hydrogen on the side where you don't want to be making hydrogen. You're precipitating your iron or vanadium where it has to stay in solution. And so how do we solve these problems? Well, we can detect it early on. So the thought process here is that if we put our sensors into the battery and our sensors can detect this precipitation when it's still at very low levels inside of the battery, then we can detect when the big clog of your piping would occur. And then we can alert the engineers so that they know to for example, decrease the voltage or decrease or increase the temperature. So they know what to do to eliminate just complete failure of your battery system.
That makes sense. So would it like just extend, I guess?
Yeah,
like,
so
in theory?
and so the end results there is that if clogs aren't occurring, you're extending the battery lifetime. If you are not generating hydrogen, which is one of the biggest causes to loss of efficiency, your battery efficiency is higher. And so we want batteries to stay on the grid and in operation for 30 years, like their theoretical lifetime. That maybe that's too hard to achieve for, because of like the laws of thermodynamics, but we can get as close as we can.
And just for reference, how long are they like staying on right now without this feedback?
Yeah, so through our customer discovery, we found that they stay on the grid for about 5 to 7 years, which is typical to the lifetime of lithium ion batteries. And one of the biggest advantages to flow batteries is that their lifetime is 3 times longer. But if it's not, then you're losing, a big gain over the biggest competitor, which is lithium ion.
Yeah, that makes sense. So, I mean, if there is any like current competition, or like foreseeable future competition, kind of what would set Flow Solutions apart from other companies?
Like competition with our diagnostic system?
I guess so, yeah.
Yeah, so there's a couple of reasons why our system kind of wins above some other ones. And so a lot of the battery manufacturers today, our customers, are using they're using data software tools to collect their data, but these software tools are coming from the oil and gas industry, from the chemicals industry. So they work fantastic for these different applications, but there's no specific tool that is used for grid scale batteries. So we bring in the electrochemical equations, the expertise in batteries, the predictive maintenance algorithms based on the thermodynamic equations that, that create the flow battery and grid scale batteries itself. And so our software wins above others because we know how batteries work and we put that into our code. And so these other companies are very good at scaling up their data processes, and they know how to collect lots of data, but they don't know how to work with batteries. And so we can handle the large amount of data you need for a battery that exists on the grid for 30 years. My CTO, Yash Hari, he worked at JP Morgan, and he's a software developer. And so he's awesome. He developed all of our software along with some fantastic help from interns. So it's just been fantastic. So that's the other one. The second thing is that we have sensing hardware that goes into grid scale batteries, and there's no other company who's making the sensors that we do.
So the flow battery market size is expected to grow a lot, like compounding growth rate, I think through 2028 is like 23%. So I guess I have a couple questions about that. But the first one is you said that people who operate flow batteries right now like do employ some sort of data analytics, but do you think it should become kind of like an industry standard to employ flow battery specific analytics like Flow Solutions offers?
Yeah, it definitely should be. I think that a lot of different industries are experiencing trends like this where you can't have one employee where it's their whole job to take the data from Excel, make plots that, make sense, do a quick write-up and send it to their stakeholders like investors or their management team, because that's someone's whole job, is their whole time. And there's systems that will do it for you in 30 seconds. And so this workflow exists, and we want to bring it to grid scale batteries because it's what's missing in this field. We can help them cut the cost and the time to understanding what's happening in their systems.
And do you expect Flow Solutions to scale with the market as it grows?
Yes, yeah, that's exactly right. So we want to be the standard diagnostic system for all types of grid scale batteries as the market explodes.
And then I guess this is like far off. I know you have like more technology coming, like 2027 is the plan, but do you think in like a distant future, would Flow Solutions just remain completely diagnostics, or would it eventually like expand into like actually making batteries or something like that?
So that's to be determined. There's a couple different, let's call it exit strategies for us, where if there's one manufacturer who finds us really valuable and they don't want other battery companies to get their hands on like the best diagnostics in the field, hopefully, in like quite a few years, then we could get acquired by a company. It would be fantastic to move more into the management of batteries. So if we're able to, like automatically send a text message to the engineer that says, lower the voltage right now, or else, like the battery's gonna explode. That can't happen for many of these batteries. And so then, it would be great to just draw the line between diagnostics and controls and become more of a battery management system company. So there's a couple of different ways that we can still like contribute to the field when we're huge.
So Flow Solutions had a lot of success with startup competitions recently. Yeah, like the Rice Business Plan, the DOE Energy Tech Up, and then Duquesne New Venture Challenge.
Yeah.
So I just wondering, I'm sure you gained a lot of insight and also won some money from those competitions. So how is that going to like translate into developing Flow Solutions as a company?
Yeah, so that's it's been probably the most fun doing pitch competitions, especially student pitch competitions, and like in the area of Cleveland, Pittsburgh, Midwest. Also, just 2 days ago, we received a $100,000 technology assistance fund from the NSF. There was a regional energy consortium, and so there were some awesome startups there. It was really great to participate and meet everyone. But a lot of these pitch competitions, they not only, give you a little bit of cash to either pay some of the contracting help you need, or we like to create internships for students. So we've had a lot of software developer internships, which have been really successful. And so along with that, they help validate your technology, and they kind of like help you believe like, yeah, this is real, this is happening. Even our earliest competitions with the University of through the University of Pittsburgh or Carnegie Mellon, because half of our team pretty much has been a Carnegie Mellon student for the whole time as the company as well. It's great to practice pitching, because every time you practice, you get that much better. So I've probably gone through like over 300 iterations of my pitch to get where I am and where I was just 2 days ago to get like that $100,000. So like just getting up there on stage and pitching, it's like the scariest thing you're ever gonna do, but it's gonna be the most helpful.
And I mean, your pitch seems pretty developed at this point. Like when you go to these competitions, are you still getting kind of like constructive criticism or like feedback, I guess, on it? Or is it kind of just more presenting the same?
Yeah, so you always get constructive criticism or just criticism. You always have people with opinions who say, like, well, grid scale batteries aren't, they're not gonna make it. The price of lithium is decreasing, and lithium ion batteries are like what's gonna make it in the future. But then you turn around and talk to someone that says like, I have this problem, you're gonna solve this problem for me, it's fantastic. And then someone else has another opinion. So everyone always has opinions about what you're doing. So you have to you can take in all the information that you can kind of like bear at any given point and then sort through it, because you know your company and your idea best.
So do you specifically have any future plans beyond Flow Solutions? Assuming like maybe other startup ideas, or just kind of moving away from it, like the startup space?
So I think, I'm going to be joining Flow Solutions full time when I graduate. Hopefully by March, I'll be graduating, walking it in the spring ceremony, and then I'll be joining the company full time. And I hope that this is, like a decade-long awesome experience, or we get acquired before that. And I don't think it's going to be my last startup. I think it's going to be my first, and I'm kind of excited for like what the next thing is and how I can keep addressing the energy transition in the future.
So I have some more like audience focused questions. But so the first one is, how did your time in Think Energy, and you also were an intern at the Great Lakes Energy Institute, impact your career going forward?
Yeah, well, I mean, in my Think Energy fellowship, I don't know if you still do it, but we formed like a small team and worked on a potential commercialization idea, and then we pitched it at a pitch competition that Siemens hosted. And so I mean, I feel like I'm still doing the same thing today. Like I'm working on my business, and I go to pitch competitions, and now I pitch not only at competitions but to investors and to potential customers. And so I think like during the Think Energy Fellowship, I just look forward to every Friday meeting and kind of just like figured out this is what I want to do for like the near term future. So it had a big impact.
Mm-hmm. And then do you have any advice for the current Think Energy fellows, or just anyone getting involved in energy startups in general?
I would say that you should talk out loud about your idea. Like a lot of people have these awesome, innovative ideas that they keep inside because it's kind of a secret, which is, dangerous, because maybe there's like, your future co-founder out there who really wants to start it with you, or maybe like there's someone who really needs that idea. So you should, like tell your friends and family, get feedback. Like if they say it's stupid, then ask them why it's stupid, and then start iterating on it, and like speak publicly about it. Like if it's protected, don't give away your secret sauce, but just like get up on stage and start pitching. And then you never know, like maybe it'll just hit and you can run with it.
So that's kind of the end of my list of questions, so seeing maybe you could open it up to anyone in the audience.
Yes, let me introduce myself. I'm Jarvis. I'm a senior undergrad at Case BME. I just curious. So I am doing a sort of pitch competition. Actually, next Wednesday. It's a 5 minutes pitch. I have 3 other teammates. So 5 minutes, 4 people pitching is really difficult. And from that practicing, I realized that everybody pitch differently. And can you share what kind of pitcher you think you are and what are your secret sauce that you have that fits you the best when it comes to pitching?
Yeah, so it's a 5-minute pitch and you have 4 people who are talking.
Yeah.
Do you have to have 4 people who are talking?
Yes.
Okay.
Yeah, it's difficult, right? But no, but we're fine. We're doing fine. We actually plan everything out already, and then we practice, and then it went pretty well. So I just realized through the process, I realized every single team member in our team a different kind of pitcher. And for example, I'm the guy who gave audience attentions and energy to catch the attention the entire time. So I am the starter. Like I'm the guy who introduced the idea. So I'm just curious whether you have like your own perspective about what kind of pitcher you are yourself, you know.
Sure, yeah, I would say, so I have 2 pieces of advice. One, I think that pitching at, like a big competition, not having like a one-on-one with, a customer, pitching is more like a performance than it is a technical presentation. And so I guess like everyone here will know, I was in Case in Point a cappella group. I don't know if anyone knows Case in Point, but shout out. And I think that like my pitch competitions now, I don't rely on my PhD expertise. I rely on standing up on stage for a Case in Point performance and like singing. And so you need to bring like the energy that you would for showcasing off your idea. Like your idea is the best idea that ever existed when you stand up and you give that pitch. So maybe like it sounds like you're leading your team in this pitch. So tell them that it's a performance. And then the second thing is whenever you're handing off within a pitch, like I'll like give the intro and then I'll hand over to Yash, my CTO, and he'll take the microphone and say, thanks, Becca, like acknowledging that you're part of the team. And then he'll talk about the next thing. And then when we hands back and I get the mic, then I say, thanks, Yash. And so that kind of makes it more seamless.
All right, thanks. That helps me to optimize my strategy next week. So thanks.
Good luck.
Yeah.
Any other questions? Yeah.
So how do you deal with like kind of like future proofing your business when like battery technology is like changing so rapidly? How do you like kind of like stay ahead of the curve in terms of like new battery technologies coming?
Yeah, that's a good question. Something we were talking about a little bit earlier in like other conversations I was having is that you need to build customer relationships before it becomes necessary. And so if there's a like very new kind of, if there's like a research group who might commercialize some battery technology, then I want to like make sure I'm aware of it, talk to someone on that team, like understand what they're doing, try to give some advice, like pretty much anyone is open to a 20-minute conversation. And so grab a coffee if you can, Zoom if you can't, and just like talk to them about their challenges, write it down. And then in the future, like when they make it big, you'll already know their company and their technology. So I say like, if in order to get ahead of the curve, just expand your network so that you are already up to par. I don't know if that's like, makes sense, but that's my strategy at least.
Jonathan.
I'm not supposed to ask questions. And then I'll
I'll go. So I have a cliche question. So, how do you balance your PhD program, research, and your startup company? And another question, like, first of all, thank you so much for your sharing experience and the startup idea, and also the whole journey is amazing. And I'm very interesting, like, how do you fundraise, other than the going to the, pitches, competitions, and do you have any, future plan, like building up your factory and everything? So yeah, would it be possible to share with that? To share that.
Sure, I'm writing down your other questions so I don't forget, but I might ask you again.
No.
Yeah, I was hoping no one would ask me that first question. It's super hard to balance PhD and company. So you need to find advisors who really believe in you and this like dual mission. So when I got to Pitt, I like rented a car from Case and I drove over to the university for my recruitment visit, and I was like meeting with advisors as I was already accepted to Pitt, trying to figure out if I wanted to go to that school. And so I talked to James, who he leads all the flow battery research at the university in chemical engineering. And I said, like, James, I want to start a company. And I'm thinking of having you as my advisor. Would you want to do that with me? And so, we had a lot of discussions about it, but we were always open from the front that I wanted to start a company. And sometimes it would be a lot of PhD work. Sometimes it would be a lot of company work. And sometimes it would be like not a 50-50 balance. And that would be hard, but like we had the conversation up front. So that's what really helped. Like the advice I will give is you need to have some awesome advisors. And so I definitely found them.
So your advisor is also your startup company advisor?
Yes, so both of my advisors are technical advisors to the company as well.
That's amazing.
Yes, yeah, they're just fantastic. And then your other question was, how do you fundraise?
Yes.
Yeah, so it's a long and hard process, and I feel like I'm learning the whole time that I'm doing it. And so I think something that really helped with the fundraising transition from PhD to, fundraising for my company is pitch competitions. And so we have been getting non-dilutive funding from pitch competitions from university and, places all over, government funding for quite a while. And so when you pitch at these competitions, you get some money. And we went to the Rice Business Plan competition in April, which is the largest graduate student pitch competition like in the world. And so when we pitched there were hundreds of investors who showed up. And so that was kind of our transition point where the feedback we were getting from investors was totally different from what we've ever gotten before from people who work at universities. And so then you start making connections with investors and you open your round and have more serious conversations about like, well, are you interested in investing? Why or why not? And then try to find the right people.
Thank you. Well, it's very interesting that you mentioned that advice you got from that specific pitch off. That do you think their advice is more, industry oriented compared to the previous pitch off competitions?
I think that their advice was more large corporation oriented. And so a lot of the judges were actual investors for small startup companies who are trying to raise anywhere from $500,000 to $1 million, which is what I would say is a pre-seed raise, which is what we're trying to do. But then a lot of the investors were more on the later stage. So they typically invest in like they write checks for like $3 to $5 million, which is kind of a different range. That's not, so I would classify them as like not the correct people to invest in us because that's too much. And so this is another example of like the advice that you get from anyone has to be taken with a grain of salt, because if the people who want to write checks for $5 million say, well, you shouldn't be focusing on grid scale batteries, you should be focusing on on the chemicals industry because it's so much bigger, then, you know, I would take that advice with a grain of salt because I know like they want to invest in companies that are taking over bigger markets right now.
That makes sense. Thank you. Would it be possible to share with us your future, you know, startup, company journey? Or like plan?
Like with Flow Solutions?
Yes.
Yeah, so we are currently now fundraising so that we can support some pilot partnerships over next year. And so we have one company who is going to pilot with us. They signed a contract to work with us, which is super exciting. And so we expect that'll start next year, and them along with some other battery manufacturers we'll work with them and incorporate our diagnostic system, validate our technology, and then publish some papers on it. And then once all of these kind of check marks are done and we know the product works in a commercial setting, then we are going to launch it to even bigger companies. And so then we'll start getting large amounts of revenue and contract manufacturing our sensors and really getting our diagnostics into the field so that we can help battery companies increase their efficiency and extend their lifetime.
Thank you so much for sharing.
Yeah, thank you.
Thank you so much for your time. This is great. Thank you to Veale for letting us join today. I wanted to jump back. You'd mentioned uninterruptible power supplies earlier. And so one of our startup teams in Think Energy last year was focused on refurbishing and redeploying UPS batteries once they were discarded, specifically from the Cleveland Clinic was their supplier. And so I'm wondering if you see the regulatory environment responding to these increased lifetimes yet, and if maybe you see yourself playing a part in how that regulatory environment could evolve with the technology. And I think related to that, as much as you're able to share, what is an early adopter profile look like for you? Because I know hospitals, super conservative, risk averse, maybe not an early adopter, maybe, but I'm curious who that looks like in what degree you can share details.
Yeah, sure. That's a good question. And this is something we're definitely looking at right now because it's like a hot topic. And so we think that there's a play with regulations because our diagnostic system can detect if a battery manufacturer actually has, you know, the different components inside of their battery as they say they do. And we can detect in a more accurate way the efficiency and the composition of the electrolyte inside of the battery system. And so this could be an easy way for regulatory entities, you know, if we're thinking like UL certifications, to get these certifications cheaper and faster. If we're able to identify some of the things that you need in maybe one day instead of a week-long visit, like one of the customers we've been talking to, they said UL pushed back on them and UL has, they're taking up a week of their time, which, you know, if you are trying to get a product out, that's a lot of money. And so we definitely think there's a play there. And then your other question, can you repeat that?
Kind of what the early adopters look like that you're running, that you're finding right now.
Yeah, so the early adopters for us in terms of our customers would be battery manufacturers. So small scale battery manufacturers, ones who have a battery that we are able to tap into in terms of their data pipeline and their actual piping, so that we can put our sensors and software into it and validate our tech and observe things that they've never observed before inside their systems. But I think to answer your question more, if you're thinking about who the early adopters are for the end users of batteries, it's commonly seen in military microgrids, where the best way to secure your energy is to not be connected to the grid. And what better way to do that than having something like a flow battery or another type of grid battery connected there. So that's just one of them.
Thank you. Is your business model solidified yet in terms of, are you software as a service, or will you sell the hardware itself, or somewhere in between?
So we are software as a service, and then with the predictive maintenance algorithms, it'll be a pay for the service that you are interested in. And so if a company is still small and they don't need that much predictive maintenance or AWS power, then they're not gonna pay as much as a really big manufacturer who has multiple batteries. And then the sensors we are selling directly. And so we'll send packages of sensors to manufacturers, teach them how to put it in or put them into the batteries themselves during the manufacturing pipeline. But the sensors are not the big money play because the sensors are gonna be relatively cheap compared to, on the order of hundreds of thousands of dollars that we can eventually in the future be charging for our SaaS. And so it would be great, in the future to just hand out sensors. They'll collect awesome data and we will just charge for SaaS.
How do you deal with like the legal side of things, like for example, like patents and regulations from the government, things like that?
So we work a lot with the University of Pittsburgh Tech Transfer Office. They are fantastic. We have good relationships with them. And so our IP, the sensor IP belongs to the University of Pittsburgh. That's how it works for grad students who develop IP. And all of the software belongs to our company. And so we are going to be licensing the IP from the University of Pittsburgh when we start working on the sensors a little bit more and start like commercializing them. Were there other legal things you said besides IP?
Like federal regulation.
Yeah, so we haven't run into federal regulation barriers yet. There are a few if you're actually putting a battery onto the grid, but because we are like a supporting technology for grid battery R&D, it's not come up yet, but I expect that's gonna come up soon for us.
Jarvis.
Oh, just curious, are you guys doing the STTR and SBIR?
Yeah, so we're applying for an SBIR in just a couple of months into early next year. We're gonna apply.
Cool.
Yeah.
I was just wondering what made you choose Pitt over other universities with flow battery teams?
Yeah, so I was accepted into a few, I think 3 different universities, and I went on my recruiting visit at Pitt and just like fell in love with the city and the department and the campus, and then I met James and Chris, and James was like, I right off the bat knew he was going to be like a very supportive person, and Chris started 2 companies already. He started a company out of grad school, and so I knew he would be a good mentor to help me with my company. There's a great entrepreneurship center at the University of Pittsburgh, the Big Idea Center, their Innovation Institute, and so they were the only university that had all of the entrepreneurship support along with having like an awesome flow battery advisor as well.
Thank you.
Sure.
We'll just do one more question.
Yep, this one's a very quick one. Are you familiar with what you sort of use in the aspect of highly available infrastructure? Just name some of the things that are key to doing software as a service, like in terms of software suites that you might be using, if you are familiar with that.
So we can talk offline about what software suites we'll be using. I'm really happy to connect you with Yash, my CTO. So he's the lead software developer.
Sure. Thank you.
Sure.
Oh, I just want to say thank you again for your time. It was very insightful. I think everyone learned a lot with that.
Awesome. Again, Becca, thank you for being here and talking with our wonderful students, staff, faculty, and others.